Today, in this video lecture, we will see numerical 1 on resolution of forces chapter. This is engineering mechanics subject, and we will see this numerical today. So, numerical is what we will find component of that force P and Q in x and y direction. So, just see here, this is x axis, this vertical is y axis, and at origin point, at second quadrant, there is P is equal to 500 Newton force is acting, and it is 25-degree angle making with that horizontal x-axis, and here Q force is acting in a third quadrant, and like they didn't provide us angle, so what we will do, we will assume here angle as alpha, and they gave us this side is 3 and this side is 4, that means slope they gave us. So with the help of slope, what we will calculate, see, like that they provide a slope 3 by 4, and this angle alpha, that means this will also be alpha, and we will calculate cos alpha. You all know that cos alpha is nothing but the adjacent side upon hypotenuse. Adjacent side is 3 here upon hypotenuse. So here see, we don't have hypotenuse, so for that what we will do, we will apply Pythagoras theorem here. 3 4, so under root of 3 square plus 4 square, so what will come, I think it is 5, right? Under root of 3 square 9 plus 4 square 16, it will be 16 plus 9 25, so yes, it is 5, so it will be 5. So cos alpha is 3 by 5, and sin alpha is opposite side is 4 upon hypotenuse is 5. So cos alpha is 3 by 5 and sin alpha is 4 by 5. After that, what we will do, we will resolve this P and Q components as a perpendicular component, and we will solve it. So just see here. Wait for a second, I take my calci. So here how we will resolve, just see here. Okay. This P force will resolve like this and like this. So what I told you in perpendicular component, whenever angle is near to that component, then always cos will come, P cos 25-degree, and here it will P sin 25-degree. So here we are going to resolve P force component as a perpendicular like that, and here it will be P sin 25-degree, and here it will be P cos 25-degree. Why cos? Because like these horizontal components, and it is near to angle is 25-degree, and this P is 500. So first what I will write here, horizontal component of P force so horizontal component of P force, I will nomenclature it as Px, because x component is horizontal, so Px is equal to P cos 25-degree. So just see here, it is in second quadrant, and second quadrant is always minus minus. So this first minus is x component minus, and second minus is y component minus. So this is minus because it is negative x-axis. So minus p is 500 into cos 25 degree. So px will be, solve it in your engineering calci, minus 500 into cos 25 degree. So it is minus 453.15. And what will be unit? See here, this 500 is in Newton. So unit will be Newton. Unit Newton. So px is equal to 453.15 Newton, and it is in negative x-axis direction. So now next what we will find? We will find vertical component of p force. So vertical component of P force, we will nomenclature it as Py because y is vertical component, and see here I resolve this force in a vertical as P sine 25 degree. So minus P sine minus y, it is minus because our force is in second quadrant, and second quadrant y is also minus. See here, just I think we are making some mistakes here. First quadrant is plus plus, second quadrant is not minus minus, second quadrant is minus plus. So remember, correct it. Third quadrant is minus minus, and fourth quadrant is plus minus. So this will be plus. This is not minus, this will be plus, and P, we know that P is 500 into sine 25 degree. So Py is 500 into sine 25 degree. It is 211.31 Newton. So this Py is positive, that means, see here, it will be like this vertical component. So our next is Q. So see, in this figure itself we will resolve it. Just remove this component. So this Q force, I think it is 300 Newton. This is 300 Newtons. And how to resolve this Q force? Just see here, perpendicular, it will resolve like this, and we assume that here angle alpha. So near to angle alpha, it will be cos. So Q cos alpha, and it will be Q sine alpha. So first we will resolve horizontal component of Q force. And we will nomenclature it as Qx, and this Qx is nothing but the Q cos alpha. Why cos? Because this alpha is near to that x-axis. See, cos alpha, and Q 300, we know that. So cos, see here it is resolved in negative x-axis, so here it will come negative, minus minus, and cos alpha we calculated it already, just type value here. Cos alpha is nothing but see here 3 by 5. So this horizontal component of Q force will be minus 300 into 3 divided by 5 will be minus 180, and this 300 is also in Newton, so our horizontal component of Q force unit will be Newton. So this Qx is equal to 180 Newton, and direction is this. Our last challenge is to calculate vertical component of Q force. So vertical component of Q force, that means Qy. So Qy is equal to, see this Q sin alpha, and it is negative Q sin alpha because this Q force is in third quadrant, and third quadrant y axis is negative. So negative Q, so this Q is nothing but the 300 Newton. So minus Q, and sin alpha we already calculated it. It is 4 by 5. So just solve it mathematically, you will get your vertical component of Q force minus 300 into 4 divided by 5. It is minus 240 Newton. Minus 240, that means at sense of that force is 240 Newton in downward direction. So just see that how we solve it. Just remember this concept is important. If your x component is this and y component is this, then in first quadrant your x component will be plus, your y component will be also plus, and this is first quadrant. In your second quadrant your x component will be minus and your y component will be plus. In your third quadrant your x component will be minus and your y component will also be minus. And in your fourth component your x component will be plus, your y component will be minus. So those concept is very important. So like your force will be anywhere, you will just apply your sign conventions like that way. So Cartesian coordinate types. So here that's why in my second quadrant for that x component I apply minus sign, and for that y component I apply plus sign, and here in third quadrant in my x component and y component for both of that forces I apply negative sign. And by that way we calculated our problem statement. So we solve our horizontal component of P force Px is 453.15 in a negative x direction, and our next vertical component of P force is 211.31 Newton in vertical y direction. So those taken directions are correct. And here horizontal component of Q force, it is also negative x 180 Newton, and here horizontal vertical component of Q force we calculated as 240 Newton downward. So with that way you will calculate any force in any quadrant. So okay, thank you very much.